Alright, this is the notes for section 8.6, quotients with radicals. What we want to do here in section 8.6 is we want to continue what we've been doing with simplifying radicals, but now we're going to look at it kind of using division, this whole idea of quotients. And from a big idea standpoint, a fraction with a denominator of the form a plus b times the square root of c can be rewritten without any square roots in the denominator. So we're going to use some of those similar ideas that we did when we were simplifying imaginary numbers and complex numbers as we rationalize denominators here involving radicals. So what we want to do in this section is we want to be able to do something called rationalizing the denominator. And really the process of rationalizing the denominator is rewriting a fraction so the denominator is rational. So what we want to do is we want to get a rational number on the bottom of any fraction. Well, we're going to look at that in a couple different ways. The first is, though, if I just have some number and then a square root of a number on the bottom, how do I go about doing that? Well, I can do it very similar to what I did with imaginary numbers, in that I can multiply both top and bottom by the square root of x. Now, by doing that, when I look at my bottom values, I'm going to have the square root of x times the square root of x. Well, if I take that's kind of like taking a square root and squaring it. Those two things undo each other, and I'll be left with whatever's left underneath that square root. So that's kind of the main process that we're going to do there. So let's take a look at this first example then. Assuming that x is greater than 0, we have this right here, and we want to simplify it or rationalize the denominator. So I have 5 over the square root of 45x. Well, I can multiply both top and bottom by that bottom value, which is the square root of 45x. If I do that, I'm left with, on bottom, I'm left with that 45x. On top, I have this stuff multiplied together. Now, if I think about that for a second, 5 and 45 can cancel out, so I'm left with just a 9x on bottom, and the 5 is gone on top, so I just have the square root of 45x. And now I've got to simplify that square root of 45x. So let's think about that. That's just what we did last section. Well, the square root of 45, that's like saying the square root of 9 times 5. And I picked 9 because 9 is a perfect square number. We still have the x there. Now I'm going to take that perfect square out of the square root. So the square root of 9 is 3. So I can say that square root like this, 3 comes out. The square root of 5x is still there. So that's where this is coming from right here. And now I have a 3 on top and a 9 on bottom, so I can simplify that one more step. The 3 can cancel with the 9, so I have a 3 left there. So now I just have the square root of 5x on top and 3x on bottom. So this is our simplified version of what we started with. Alright, so we want to look at rationalizing again, but now we want to look at it when the bottom includes a sum with a radical on it. So something of the form a plus the square root of b. Okay? Well, to do that, we're going to use the concept of conjugate again. So what we're going to do is we're going to multiply top and bottom by the conjugate of the bottom value. So if I have a plus the square root of b on bottom, the conjugate of that would be a minus the square root of b. So I'm multiplying the top and bottom by that value. And by doing that, I will always end up with a squared minus b. So let's go through that process with this example right here. I have 2 over 3 minus the square root of 5. And we want to write that in a plus b times the square root of c form. Okay, so on the bottom, since I have 3 minus the square root of 5, I'm going to multiply by the conjugate of that, which would be 3 plus the square root of 5. And if I do that on bottom, I have to do it on top as well. Now on bottom then, that's going to leave me with a squared, which is 3 squared, minus b. B would be 5. So that's 9 minus 5, which is equal to 4. So that's where this 4 is coming from. Now on top, when I multiply 2 times that, remember that you want to think of this as being in parentheses. So it's really like saying 2 times, in parentheses, 3 plus the square root of 5. and then I've got to distribute that 2 to both of them. So that's why I'm getting 6 plus 2 square root of 5. Okay, to finish off then, what I'm going to do is I'm going to simplify that by splitting it up. 6 over 4 gives me 3 over the 2, and then 2 and the 4 can cancel out here to give me this. So I have 3 over 2 plus the square root of 5 over 2. So that would be my answer.